Can anybody tell me what is the units of Newton's second law of motion? That is what we can say. Force is equals to m into a. Is it yes or no, guys? Mass into acceleration is the units of force. Yes, please. So formula.
Yes,
So it's the axle. Always Newton's second law of motion will give you the relationship between two things. One is what? One is force, and another one is what? Acceleration. Okay. So now when it comes to the units of force, we'll be having two units of forces, two different kind of units of forces, which we already studied in the last class. One is what? Absolute unit, and another one is what? Gravitational unit. So if we'll take absolute units, and again they'll be having a two types. And what is the two types, guys? Anyone?
SI and CGS, sir.
SI unit, and another one is what? CGS unit. So that is what we have studied. And same way, gravitational units also will be having two types. One is SI unit, and another one is what? CGS unit. So if it comes to here, absolute units of force. So what is absolute unit of force? Two things. One is Newton. Another one is what, guys? One is Newton. Another one is what? Dyne. So and we have been made a relation also. 1 Newton is equals to how many dynes? Anybody can tell? 1 Newton is
10
equal
power
five.
5 dyne.
10 power 5 dynes. Simply don't listen and note down the notes also. Strictly follow the notes. You have to learn. If you want to improve, you have to learn that. Next, coming to the gravitational unit. Danishkar, can you tell me what is the SI unit of gravitational unit of SI system? Newtons? What is that, guys? We can call it as kilogram weight, or we can say what we used to call kilogram weight. Or we can say what we used to call kilogram. Understand? Same way, if we take CGS unit, what we used to call gram weight, or we can say gram force. Okay, so that is what it is. Yes or no, guys? Please respond. Gram weight or gram force. Now, 1 gram weight is 1 kilogram weight is equals to how many newtons? Anyone? 1 kilogram weight is equals to how many newtons? We have been found yesterday.
9.8
Newtons. Very good, Mitaksri. Mitaksri only studying, others and all not at all. Next, same way. Also, we know that 1 gram weight is equals to how many dynes? Everyone, 1 gram weight is
980.
980
Yes, very good. So 1 gram weight is equals to, we know that how many dynes? 980 dynes. Understand? So till here we have been done in the last class. Any doubt? Anybody? Please note down the notes. Mainly Kaushik. Write the notes properly. Vartini, you also, and Danishka. Danishka, have you understand Danishka till here? Any doubt? Now, in our today's class, we are going to continue again from the last class. That is what? Impulsive force and as well as impulse. Okay, right. Those who not understand last class and those who are incomplete, you can write. Impulsive force and impulse. Impulsive force and impulse. Shall we start, everyone? Now, first of all, try to understand impulsive force, and later we can understand what do you mean by impulse. Now, if it comes to here, as I told you, within a fraction of second, if you'll hit the door, if you'll knock the door, means in the sense of the momentum of a finger is reduced to zero in a very short interval of time, so that the resultant force means the imparted on the door is very large or very short, so that our finger will hurt or not. Within a fraction of seconds, your finger will come to rest. Means suddenly, like you knock the door, so that your finger will hurt or not. Yes, please respond. Yes or no? Yes, it will hurt, because as we are know that the moving finger has momentum. Now, once the door is struck, struck, the momentum of the finger is reduced to what, Hari? The momentum of the finger is reduced to zero. Understanding? Whenever our finger will touch the door, that is what struck the door, then the momentum of the finger is reduced to zero in a very, very large interval of time or short interval of time? Very, very short
interval.
interval of time. So,
Short interval of time.
yes. So as a result, understand what will happen. The force imparted on the door is very, very large in a short interval of time. That is why finally what will happen? Our finger will hurt. Yes or no? Finger will hurt during short or sharp knocking the door. Okay. So that is why when we are knocking the door, we have to knock normally. If you sharp within a fraction of seconds like this, then definitely it will hurt. For example, see, you might be all experienced. Suddenly our knee or this elbow, you can notice it. Elbow will touch to some kind of surface suddenly. Then you will get a vibration for a long period of time. Do you remember? And it will be very, very painful also. Have you experienced anybody like that? When our elbow will touch to the any objects and near objects, unfortunately, then you can see our hand will get like electric shock and it will be more painful. It will take some time to getting relaxed. Yes or no, ready? Have you experienced that? Yes or no?
Yes, sir.
I experienced.
Yes,
I
sir.
experienced. I have good experience. So more painful it will be because when we are unfortunately hitting that any hard surface or anything, then within a fraction of second, what is happening? Momentum of our hand become within a fraction of second, momentum of our hand become zero. Understanding very short interval of time, so that large force will be imparted on the door. So that is why it will be hurting our hand or finger and all. So this is only called as impulsive force. Understand? The force acting for a short interval of time is called as, what was to call, guys? Please respond. Impulsive force. Okay, right. Large
Impulsive
force, large force, large force acting for a short interval of time. Large force acting for a short interval of time. Acting for a short interval of time. Short interval of time is called as, what was to call, guys? Impulsive force. Are you clear? Ready, Danishka? Open your mouth. Arun Kailas, you also. That is what. So, more force if you are applying for a short period of time, then that is called as what force? Impulsive force is to called as. So,
Impulsive
what
force.
you can take it here is a product of force and the time during which the force act is only called as impulse. So this product of this time and force only we is to called as, what we is to call? Impulse. Understand? That force is called as impulsive force, and that impulse means it is a product of large force which we are applying into, what is that word? The short time period which we are applying. That is only called as impulse. Impulse means what? Force into what, guys?
Time.
Force into time. Very good. So that is what we can say. Okay, make it now. Everyone, till here, any doubt? Yes, please. So definition also, if want, you can write. What is the definition we can write, Hari? Anyone? What is the definition you can write here?
So,
Right. The product of force and time, the product of force and time, the product of force and time during force, during which the force acts, during which the force acts is called what? Is called impulse. Okay, that is what. So now this is what the formula. Now if you notice it very carefully, impulse is equals to, I can write force into time. So but we know that from Newton's second law, what do you mean by force? Newton's second law, what do you mean by force? Force is equals to what, guys? Please respond. Mass into acceleration.
Momentum.
Now, in place of F, can I write it mass into acceleration? Yes or no, guys? Is it right or wrong? Everybody.
yes, sir.
Metakshri, Vartani, what will happen? Impulse is equals to what is the formula? Tell me. Impulse is equals to what will happen? In place of force, I can write mass into acceleration. Understand? Acceleration into time period. Is it yes or no? Yes, please. Anyone?
Yes, sir.
Will you accept it? Right or wrong, guys? Is it right or wrong?
Yes.
That is what.
Yes,
So
sir.
now I can say impulse means simply in English word. What I can say English word? Mass is m, acceleration is a, time is t. So can I say it is equals to mat? Yes, please. Impulse means what? Impulse means what? Mat.
Math.
That's all. Now, shall we simplify this formula? Everybody, are you ready? Shall we simplify this formula? Yes, Akilan?
Yes, sir.
Akilan? Now, you people can simplify very easily. We know acceleration. Acceleration is equals to what is the formula? Please respond. Acceleration is equals to, you have to tell me, final velocity minus
minus
velocity divided by time period. Is it right or wrong? Is it right or
Yes,
wrong?
sir.
Now, let me imagine this is equation number 1 and this is equation number 2. Now, substitute equation 1 in 2. What will happen, guys? Substitute equation 2 in 1. What will happen, Hari? Everyone tell me, try to answer. Arun Kailash, not at all opening the mouth. Impulse. Impulse is equals to mass is mass only into, in place of acceleration, what I can write? In place of acceleration, v minus u by t into again time period. Now something will get cancelled. Anybody? What is the credit?
Time and time and time
Sir.
and
Will get cancelled. Yeah, very good. Now impulse is equals to mass into final velocity minus initial velocity. So mathematics, a into b minus c. How the formula will come? ab minus ac. So that what will come here? Mass into final velocity,
MV minus
mass into initial velocity. So this is only we used to call as, what we used to call? Impulse. Okay. So this is the another thing. So finally, impulse can be defined as what we used to call? Impulse means what, guys? Change in momentum. Yes or no, Hari? So what is this? Observe very carefully. What is this called as? Anybody can tell? What is this called as? Change in momentum. Yes or no?
Change in momentum.
Change in
Yes,
momentum.
sir. Final.
Change in momentum means we know that. What is the change in momentum? Change in momentum P is equals to final momentum minus initial momentum. Yes or no? So which is equals to mass into final velocity minus mass into initial velocity. Right or wrong? So again we went back to the same thing. Yes or no? Impulse means what? What do you mean by impulse? Impulse means what is change in momentum. That's all.
Change in velocity.
Went to same thing. Do you notice that? Everybody? Yes, Arun Kailash,
Yes, sir.
Yes, sir.
Kaushik, are you write it down or not? Mr. Kaushik, simply sitting.
Yes, sir, writing, sir.
Yeah, that is what. Have you understand, guys? Everybody? Yes or no?
Yes, sir.
That is
Yes, sir.
what.
Yes, sir.
Like momentum, impulse is a vector or scalar quantity. Momentum is a scalar quantity. We people knows that. Sorry, vector quantity. So now, is it momentum is a vector quantity means then impulse is also a what? Impulse is
Vector
also
quantity.
vector quantity only. That is what you have to remember. Any doubt till here? Please respond. Clear, everybody? Yes,
sir.
please.
Yes, sir.
Any doubt? Gokul? That is what. Is it interesting or not?
No, sir.
Is it interesting?
Yes, sir.
Yeah.
Yes, sir.
Now, one thing I'm saying you don't have any impulse word in your textbook, but exam they will ask you calculate the impulse. Okay, if you want last year papers also you can take and see. They have given so many questions to calculate the impulse. Impulse means what? You no need to worry. Impulse means something big. I don't know. What is impulse means? Mad. Understand?
Change in
Impulse means mad, or we can say change in momentum.
momentum.
Okay, now this is all about it. Are you clear, guys? Any doubt? Next, units of impulse. Please, all of you write. Units of impulse. You should say, guys. I should not say. Units of impulse. Shall we start now? Units of impulse. Everybody.
Yes, sir.
Now we know that impulse is equals to what is the formula? Impulse is equals to force into Force into time. Force into time. Is it yes or no? Yes, everybody. Is it right or wrong?
Yes, sir.
Force into time. Now let us discuss units of impulse in SI system. If we'll take SI system, shall we go with SI system? Everybody? SI
Yes, sir.
Yes, sir.
SI system, observe very carefully how it will be coming. So SI system unit is Newton second. What is the unit, Hari?
Newton
Second. Why it is Newton second? What is the unit of force? Unit of force is
Newton.
Newton. Time is second. That's all. So if we multiply Newton second, that is the unit of SI unit of impulse. Any doubt? Now,
No, sir.
now, same thing we can write in another form also. That is what in form of kilogram meter per, that you tell me. In another SI unit, again SI unit only, another SI unit. I want that. Anyone? In place of Newton, I can write something. We know Newton is
Time.
equals to what? 1 Newton is equals to what? Everybody should tell. Kilogram meter per second square. Yes or no? Everyone? Yes or
Yes, sir.
no? Respond. Or else. I know that is from the second formula I'll get it. What is another formula for impulse? Impulse, another formula, MAT. MAT. Yes or no? Now, what is the unit of mass? You should tell me, kilogram. What is the unit of acceleration? Meter per second square. And what is the unit of time? Second. Yes or no, guys? Yes, please. So now, can I get cancel 1 second and 1 second square? Hurry. Gokul.
Yes, sir.
Everyone right or wrong? That's all. Then what is the remaining thing? Kilogram, meter per
Per
second.
second.
That's all. So that is the unit of what? Unit of impulse. Okay. This is also SI unit only. Which unit? SI unit only. So this unit is already you studied for something. Anybody can tell what is that? You already studied the unit of this one. That is what? Momentum. Momentum is equals to what? Mass into velocity. So unit
Velocity.
of mass is what? Unit of mass is kilogram and unit of velocity is what? Meter per second.
Meter per.
Is it the same or not? Yes or no?
Yes, sir.
That is
Yes,
what
sir.
you have to remember.
Yes,
So
sir.
SI unit of SI unit of impulse is either Newton second. Newton second. How to read this one? Newton second. Understand? Newton second, or we can say kilogram meter per second. Is it okay, Akilan? Arun Kailash? Please speak, guy. That is what. Okay, next. CGS system. Anybody can tell what is the CGS system? CGS system. Very simple. Already we people knows. So what is CGS system? Newton second. Here CGS what will come? Dyne second. That's
Time, sir.
dyne second. Understand? So that is what it will come. Nothing. Why are you ring? Make it dyne second. Or dyne second. Or another unit what? Gram
Gram centimeter per second.
gram centimeter second. This is what CGS unit. Please all of you note it down. How this gram centimeter second will come, you know or don't know? You know or don't know, guys?
So you taught already.
I already taught you. Yes or no? Because MAT means what is the CGS unit? Mass impulse equals to what is the CGS unit, guys? Centimeter. Sorry, grams. Acceleration centimeter per second square. Time seconds. So square and seconds will get cancelled. Gram centimeter second will come. Yes or no? Kaushik, Mr. Kaushik, Akilan, that is what. Okay.
Yes, ma'am.
This is what the impulse SI unit and CGS unit. So please all of you note it down. And so many morning you will not at all wake up by 5 o'clock. Please kindly wake up and you have to learn it. And you have to get ready for school. Okay. So this is all about it. Any doubt, guys? Please respond. If I have any doubt, you can ask me. Clear? Everybody? So this is all about what is impulse. Please make it. So impulse means you have to keep, as I told you, it is velocity. So we have to keep in formula up arrows. Here, everybody should keep up arrows. Arrows should be arrows, you have to keep it. Okay. So that is also another formula of impulse. So be very careful. Mass here, you have to keep arrows because it is which quantity? Which quantity it is? Vector or scalar? Vector quantity. That is
Vector quantity.
arrows. Is it okay, ready? We have to keep arrows because it is vector quantity like momentum. Everybody. So till here, everyone finish it till SI and CJ system. Then we'll go for okay
Yes, sir.
applications of Newton's second law of motion. Shall we go with applications, everybody? Are you ready? So a lot
Yes,
of
sir.
we are having. So let us discuss what is that application and how it is useful for us. Everything we'll study. Now, if you open in our textbook, all you can see there itself will be having applications also. You might be take the page number. Till now, what we studied is not there in book, but you can find the applications. Page number 59. Everybody see page number 59. Do you have page number 59? Yes, please. Everyone. So catching a cricket ball, they are saying. What is the catching a cricket ball? Anybody? That is what dimension, that is what you can say. Catching a cricket ball. Everyone see that. So what is the person is doing? He is catching the cricket ball. What will happen, Hari? If we'll try to hold the cricket ball directly without down our hands, then what will happen? That is what I want. Anybody? Yes, please. What will happen? Why the person? Yeah, why the person will move his hands back when he is catching? Why can't he hold it directly? Anybody, girl or boy? Mitakshri? That is what. This is the picture you are seeing in our textbook. Is it the picture? Figure number 20 and figure number 21. Yes or no? Yes, please.
Yes, sir.
So now what is happening here? A cricket player, if you'll see, move his hands backward and catching a fast cricket ball. So why he is moving his hands back? Anybody? So cricket fielder lowers his hands while catching a ball. Why? What is the reason? Because if the ball is caught without lowering the hands, then what is happening, guys? Anybody? If suppose if a person see here after catching the ball, the hands are keep on going down or not? Yes or no, Gokul, Hari, everyone? Now, if you notice it very carefully,
Yes,
if
sir.
you are all also cricket players. If you try to hold the ball directly, then what will happen? Anybody can tell? Anybody can tell what will happen? So if you try to hold it directly without lowering your hands, within a fraction of second, what will happen? Fraction of second, what will happen? Fraction of second, momentum will become what? Momentum will become zero. Understand?
Zero.
Velocity, suddenly, velocity become what? Zero. So momentum becomes zero. So that it will exert huge amount of force in where? Exert
In
huge
the hand.
force. Exert huge force in our hands so that it will hurt our hands or not? It will hurt our hands
It
or not?
will
It will hurt. Now, after holding the ball, if I keep on moving our hands in backward direction, then what will happen? After holding that, then from here to here, time period is increasing. If the time period is increasing, so that what will happen? The force will decreases. Force will decrease.
decrease.
The force will
Decreases.
means exerting momentum, what will happen? Momentum will become zero after traveling little bit more distance. Yes or no? So the momentum will comes to the velocity slowly decreases. Velocity decreases slowly so that momentum also exerting the force or momentum exerting on our hands is decreases when we are moving the hands backward. Have you noticed it here? The person after holding the ball, he is trying to move the hands backward direction. Yes or no, guys? Here in this picture also you can see after holding the ball, the person is trying to move the hands, lowering the hands in the backward direction. Why? So that the ball can travel little bit more distance, so that velocity decreases slowly instead of drastically, so that the exerting momentum or force on our hands will be less or more? Will be less, so that it won't hurt our hands. Is it okay, guys? That is what. So the fielder will hurt his hands due to a large force when he is not trying to lower his hands are trying to catch the ball directly. Is it okay, Mitaksri, Akilan, Arun Kailas? You all people are cricket players only, correct? Gokul Krishna, Gokul every time used to play. I know that Daniskar also. So while you are catching the hands, automatically, while you are catching the ball, automatically our hands will go backward. Is it yes or no? Yes?
Yes,
That
sir.
is why. Because to reduce the force, understand, if it is not, it will exert more force, large force, so that it will hurt our hands. That is what you have to remember. So that is why when the ball is caught by moving the hands in the direction of motion of the ball, and that also how we have to move the direction. Anybody hands, for example, ball is coming like this direction. Now if suppose he will move his hands in forward direction, it will hurt or not? If we have to move the hands forward or backward direction, but suppose ball is coming like this now, so our hands also should go in the same direction. Yes or no? Yes, please respond. Now the ball is coming like this, the ball is coming like this, so that the boy need to move the hands like this or like this upward, downwards. Yes or no? So we have to move our hands in the same direction of motion of the ball. Is it okay, Mitaksri? Yes, please. So when we'll move the ball
Yes,
direction,
sir.
the same direction of motion of ball, then the duration of the impact increases. Understanding? The duration of the impact, what will happen? Duration of the impact will increases. So that what will happen? As a result, the rate of change of momentum decreases and the force exerted by the ball on the hand is reduced or increased, guys. If you move the hands, it will be reduced. Understanding? That is what you have to remember. So that is why while you are catching the ball, always we have to move the hands in the same direction of motion of the ball, so that the impact time will increases. What will happen? Impact time will increases. So if impact time will increases means rate of momentum, what will happen? Anybody, boys, girls? Rate of momentum, what will happen? The rate of change of momentum decreases. Okay? Rate of change of. So rate of change of momentum decreases. So that what will happen? Rate of change of momentum decreases. So that what will happen? It will impact less, or it will reduces the force exerting by a ball on our hand. That is what the first application. Any doubt? Anyone can ask me. All the boys, Kaushik, Reddy, Taniska, clear? Everybody? That is the first application. Next, second application. They given in our textbook alone. What is the second application? Read everyone. What is second application? A person who jumps, that is what? High jumper. The case of high jumper, if you'll notice it, so that what will happen? High jumper case, anyone? He will always will fall forward or backward. He will always will fall
Forward.
forward or backward. Anyone?
Backward.
Backward already. Backward means that's already, then you will never. Okay. And also see, always we'll arrange some kind of soft sand or something for jumping or long jump or high jump and all. Why we are doing that? Anyone? Why we are doing
Safety
that?
landing, sir.
That is what. So now you can see, all of you observe this picture which is given in our textbook. See, observe very carefully, all of you, what they are saying there. Read everyone. So now you can see an athlete taking long jump or high jump, both, he will bend his knees before landing. Why he is bends his knees before landing? Here you can see, guys. Why he will bend? He is bending long jump or high jump, whatever it is. Both they will bend his knees. Okay, before landing. Why it is? I want to know that. Anybody? Yes, girls, boys, anyone? Try to think and tell me. Long jump, the athlete taking a long jump or a high jump bends his knees before landing. Why it is? Anyone? Please respond. For example,
So that he
let's
can
take,
reduce the force.
not reduce the force, you have to speak some other thing. Any other? Now,
Reducing the momentum.
yes, Mitakshri, how it will reduce the momentum? That is what I want. by increasing the time. Impact time should increases. Yes or no? Impact time should increases or not? Impact time should increase. Now, I am asking the question, should increase. So that what will happen? Impact time should increase. So that what will happen? The rate of change of momentum will decrease or increases? Decreases. Yes or no? So that the force exerting by the ground or else by the ball will decreases on our hands or legs. Now you can see. Now I have been conducted long jump for Harish and as well as let me take now Reddy. Now Harish has landed without folding his legs and Reddy has landed directly with folding his knees. Okay, with folding his knees. Now you tell me who will touch the ground first, Harish or Reddy? Anybody? Yes, please.
Sir, Harish.
Harish will touch the ground first, so that his impact means the force exerted by the ground on him is more or less. Is more or less.
More.
Why?
More, sir.
He is coming and hitting very forcefully the ground. So whatever the force he will hit the ground, in the same force the ground will hit him back. So that may leg will damage or may leg injury also. But Reddy case, what is happening? They will bend his knees before landing. Why he bend his knees before landing? Bend his knees.
Sir, you can reduce the time.
Yeah, bend his knees, understanding, before landing, because so that impact time will increase or decreases. Ready? Before landing, increases. Understanding, impact time will increases. So impact time will increases means, so that you can see, for example, I am jumping like this. So my legs are stretching, so that more faster I will touch the ground. Yes or no, guys? Yes, please respond. So that more force, more rate of change of momentum is more, so that it will hurt your leg more forcefully. Now, if I'll bend my knees, what is happening? My legs, it is taking some time to land, touch the ground. Is it yes or no? Yes, please respond. So still I will be like little longer period I will be in the air, so that the force will reduce us, the exerted force will reduce us on the ground, so that understanding no injury will be causing from the ground. So that is why what will happen? Increases the time of fall. That is what we used to call impact time. That is what if you increase the time of fall, then rate of momentum, what will happen? Rate of momentum will decrease or increases. The rate of change of momentum gently reduces and the impact of fall will be less. That is what it is in the case of high jump and long jump. So it is also real life application or not? Partini, Mitaksri, Arun Kailash, that is what you have to remember. So if you increase the time of fall, so that impact, the force exerting by the ground will be less. That is what change in momentum, so that it won't hurt our legs. That is what. Third application. Anybody? Third application, read in our book. What is that third application? You are having already. That is what? The use of seat belts in cars. Why they are providing seat belts in cars? Anyone? Why they are providing seat belts in car? Yes, please respond. To provide, to understanding. That is what, to prevent injuries. Nowadays, it is necessary to wear the seat belt once you are sitting in the driving seat. Even not only that, backside seaters also nowadays getting the seat belt. Yes or no? Yes.
Yes, sir.
Yes.
sir.
Because to prevent the injuries in the case of accident. To prevent the injuries in case of accident. So what will happen? Observe this picture. You can explain. I will explain you. So as we know that you all people, are you kept the seat belt till now? Anybody? Are you having experience or not with the seat belt? Yes or no? Yes, please respond. Do you have experience with the seat belt? Try to expand, communicate, guys. Now, if there is no seat belt, if a person will hit by the accident, then what will happen means the person will be thrown away from the window, from the front glass. Is it yes or no? Have you seen here? The picture, the person is thrown away from the front glass if there is no seat belt is wear. Yes or no? And even see the back persons also, they will hit the front seat and very badly they will injure. Is it right or wrong, Akilan? Yes, please.
Yes, sir.
That is, meeting is going to end, join back and we'll discuss it. Now, why it is very badly it is injured or the person is coming out when they will hit by an accident? Front accident. What is happening? Front accident. If you have been hit by, you have been hit anyone, then a person if not wearing the seat belt, he will come out. And back